Hello there. In this short video I would like to show you how to plot the continuous variables in R. For that I'm going to open RStudio. Here it is. The dataset that I would like to use is contained in the package hsaur3. If you don't have that package installed, we can click on install here, type in hsaur3, enter and install. And the package is automatically downloaded and installed, and you will definitely have the package available here. We click and it is available. The dataset that we would like to work with is called US melanoma. So we're going to load the data first. Data US melanoma. Okay, and it is available here. Okay. For good practice, we're going to also open a new R script, and we're going to add in all the relevant commands there. So I'm going to add in this command up here as well as this command here. So we would have then a reproducible script. Okay. What is in this data set? We can definitely ask R help US melanoma. Okay, and here's the description. It contains a data frame with mortality of white males that died due to a particular melanoma at the middle of the last century, per 1 million inhabitants. So even though it seems like we have a count here, it is much more like a rate. We have latitude and longitude of the geographic center of the state, and an indicator variable whether the state is adjacent to an ocean or not. Okay, so the form of the data frame is 49 observations of 4 variables, so it looks like the state y is not part of it yet, and we have, as described in the help file, mortality, latitude, longitude, and ocean. Okay, so we're mainly interested in the variable mortality here for the moment. So US melanoma dollar, we access this variable through the dollar construct mortality. This is the variable here. Okay. Let's first draw a box plot thereof. Box plots are constructed with the function boxplot, and boxplot of this variable. Okay, I'm going to execute this command, and here is the result. This is a rather simple form here, so maybe we should add a title here, maybe. And melanoma, for example, and that is then with the argument main. And as for the Y-lab, let's argue that we call this mortality out of 1 million. Okay. Make a line break here, it's a little bit better visible, and eliminate the spaces. That's it. So as a result, here is the new box plot. What do we see in this box plot here? Smallest number, largest number here, smallest one just below 90. Here it is around 230. This is the median, and here we have the lower quartile, the upper quartile. The number of these values can also be accessed through a summary. As a matter of fact, the box plot just graphically displays the 5 most important summary statistics of the data set. Okay, and here are those 5 values: minimum, maximum, first quartile, third quartile, median, and mean. Median and mean are quite close to each other, so the data does not seem to be off too much from a symmetric distribution. To have a better look at the shape of the distribution, we can plot a histogram. Histogram of the same variable here. And that's the histogram. There seems to be a second peak here, but that's not really significant. It's just a couple counts additionally. This is the bin width here, the width of these rectangles, the bin width. That can be changed, of course. We can, of course, also change the title, the label description, colors, etc. All those arguments are described in the help of hist. One important argument, however, is whether I want to depict frequency or, say, the density. For a density, I would put here prop equals true. Okay, there's the density. Okay, now the question is there a difference between the mortality rates and whether or not we have a coastal state or a land state? For that, we could plot 2 box plots, one for each group. This can be achieved very nicely through the following call to plot. So we will plot the mortality as a function of ocean. And we take the data set US melanoma. Notice that here I don't have to specify US melanoma when I use this data equal construct. Okay? I'm going to execute this and I'll have 2 box plots. Of course, I can also add a title here. I could probably retake the same title as what I had above. So mortality of melanoma. Control V. And maybe this no yes should be changed, and we could add in whether we have I don't know, a coastal state or not. We can also play a little bit with that, of course. Okay, run here. This is the box plot that I'd like to see. Okay, so we see a difference whether we are coastal state, a higher mortality rate. Later on in your statistics module, you will see whether this increase is really significant or whether that's just by chance. And here we're going to just look a little bit at the graphical interpretation thereof. Okay, so next I would like to plot and compare the histograms or the densities of those 2 groups. So of course I can construct a variable here. Maybe I call that mort.yes, and in that variable I'll put all the mortalities from, say, coastal states, and I would subset that through the variable ocean, and we have a coastal state when this variable is yes. So let's check what I've just done. This variable here tells me yes or no we have a coastal state. Here I'll compare, and I have true falses. I have a true whenever I have a yes, i.e. I have a true when I have a coastal state, and I'm only going to pick the values from the coastal states. So here, when I run this, I'll get only the mortality rates from the coastal states. This sequence of numbers was used to construct this right box plot. Similarly, oops, that was not what I wanted to do. Undo. I can construct the mortality no. No here. And now I can start to plot densities. So instead of a histogram here, mod yes with prop equals true. Now I need to execute those commands, of course. 1, 2, 3, voila, here. Instead of that, I'm going to plot a smooth version of this histogram. And I'll do that with plot density that smooths this histogram of mod yes. Run. Here is the density. Oh, maybe I can just superimpose it here for the illustration. This is the histogram. Instead of plot, which creates me a new figure, I'm going to add in lines. And there is the superimposed smooth histogram. Notice that for that I really do need here a density, such that both the histogram and the curve are on the same scale. And of course I can start playing here with colors and all other aspects here. Okay. Okay, let's revert that back to plot. Okay. And then I'm going to add the second density through lines, because I want to superimpose it on the previous plot. Mort, no, superimpose. Two aspects that we should consider here. One is, well, I need to change the range of the y-axis here, and the second, I should probably choose different symbols here, or different colors for the lines. Okay, so here changing is that to y lim, and I would like something from, say, 0 to, that's probably going to be 0.018, huh? Let's check that. The title here should be removed because it's not only for mortality yes, but also for mortality of the land states. So main is empty. Okay, and here I'm going to choose a color number 3, which is green, and maybe a line type 2. I'm going to rerun those two lines, and there it is. Okay. It's always useful to add in a legend. I'm going to place that in the upper right corner. The legend text is for coastal state. And land state. colors that we've used is 1 black, green for land state, and the line types is 1 and 2. So I could write that as 1, 2 or as 1 colon 2. Execute it, that's perfect. I typically don't like this box here, that's just a little bit too much. So I'm gonna eliminate that by bty. No. Okay. 1, 2, 3, 4. That's it. Yeah, voila. Nice, beautiful figure here. Well, maybe we should remove this X lab as well and just lab here, write this as what should we write there? Probably mortality. Something like that. Okay. There it is. There is another aspect that we could have a look at. For example, is there a dependency of mortality rate on latitude and longitude? So let's see, we could call plot mortality, and now instead of ocean, what I had before, let's call, say, longitude. Data equals US. Okay, so compare this new line that I'll hit enter with this line here. Okay, enter. A bunch of points. There does not seem to be any structure between mortality versus longitude. What about latitude? I'm going to replace here latitude. Voila. Yet we do have dependency here. So I'm going to copy this line up there. Okay. And we could work on that. We can again change the labs, the title, etc. But maybe it would be interesting to see which of those observations are from a coastal state and which are from a land state. So what we could do is we could change the plotting symbol, and I would choose a symbol according to the ocean variable. 1 and 2. So these would be for land, and these would be for coastal. Careful, why is that? Well, let's have a look again at US normal ocean. Okay, so the first is a no, so no would be a 1. I'll select 1 corresponding to a circle. Always please check and make sure that you have the correct labels for it. So here we would also add a legend, very important. C, and we would have here rather PCH. And should we keep color here, so we could then also change the colors. And here we have first the coastal state. Coastal state is symbol 2, so we need a 2 here, a 1 here. Okay, and then we have no separate color. Land and coastal, And if we would nevertheless like to add in colors, we could that through the same construct as for the symbols. See, oops, that was too much. Undo. Okay, I'm going to copy that. Okay, and I would choose color green for coastal. As before. And so then here, sorry, green for land. Green for land here. Alright, yeah, okay, land here, coastal there. Okay. So here we've seen a few very handy R functions. First, boxplot to summarize summary statistics from a data set. Histogram, plotting as it says, a histogram. The plot function is very powerful and allows us to plot histograms, point clouds, etc. Plot decides on the variable we hand to the function on how it should structure the plot. Okay, so it can be from a scatter plot, plotting a density line, or box plots. Of course, R has many more functions that allow us to plot more or less sophisticated data sets, but we see those at a later stage.